It's a long time since I've been on a stage. So, hello. Yeah, we're from Ascential. I'm Nick. This is my co-developer and also boss, Steve. So all the good code is his and all the crap code is mine. We're Ascential. We're a fairly large FTSE 250, so ish large, business intelligence and events company. And we're a very small cog within that.
We're a cult.
A cult. We're a very small cult within that. Cog, I said. But I'm going with cult. Cult is good. We are a cult as well. We're at the moment, one of the many things we're working on at the moment is producing an app to support one of our events. We run big events around the world. Things like Cannes Lion, which is sort of the Cannes Film Festival, but for advertising, happens a week later. It's quite a fun place to be. This specific app is for Money 2020 Asia, which is next month in Singapore. There are a number of Money 2020 fintech events around the world for the fintech industry. And we're writing apps to support all of those. And basically what we want to talk to you tonight about in a very rough and ready way is the journey we took bringing our first Flutter app to the market. And when I say the market, I mean the App Store and the Play Store tomorrow at midday. I've got a shed load more work to do tonight. So we may be running quite quickly out of here afterwards. It is going to be a bit rough and ready. As you can probably imagine, we have been concentrating a little bit more on the release than on the presentation. So what we want to do here is more of a workshop, more of a description of the way we've gone about going from no knowledge of Flutter, but quite a lot of experience in this sort of world for a number of years between us, to bringing an app to the stores, to building up a team that will continue to build and enrich and support that app going forward, but in a very conversational style. And I will pass you over to Steve, whose baby, the front end, is far more than mine.
Okay. Hello. So this is the app. So this is almost the same code that is going to go to the Apple App Store tomorrow, unless we find anything really horribly wrong with it. First thing is, one of the things that's been really attractive and wonderful about Flutter has been the ease with which one can do testing. We haven't done any of that on this. So first admission. There are two things I want to point out about that. One of them is that we're still figuring out how to do things. We'll probably end up rewriting the whole thing over the next 6 months anyway, with tests. Now we've figured out what we kind of want to do. So I'm just going to put that in there as a thing. The other thing we found, though, is because of the analyzer, because of the strong typing, because of the just the way the whole developer experience has been put together, we found that we can do quite extensive refactorings, get it so that Visual Studio Code says there aren't any problems, run it, test it all, and it still works, which has been quite amazing. So there's this kind of pro and con thing. There's like, it's really good to do tests, and on the other hand, it's really tempting not to because it's actually so good without them. What we'd like to do first of all is kind of just give you a tour of what the app is, because I think Flutter's quite new, and it's kind of interesting. I've always been interested to see what apps people have done in them, what kind of interactions there are. There are a few interactions there I want to point out from a Flutter point of view, where it's been quite challenging in Flutter, and how we've approached doing that. Overall, the app runs on what do you call them, phones. And it speaks to an Elixir backend. So we like the setup Elixir, Phoenix, that kind of thing. For those of you who know that, it's kind of a bit like Node.js but different. And it talks to one of those on a sort of JSON API. So that's the sort of how it talks to things. Let's have a little tour of the app. Nick, could you log in as someone so we can see what goes on? So this is an app that's used by people who attend this event. So these are people who've paid several £1,000s for a ticket to an event all about fintech, with the latest fintech stuff, to meet other people and also figure out what's going on at the event and have a good event. There's so much going on at these events. We've tried to make an app that helps people to plan them. So we've got an extensive sort of user experience department. Both of us are a bit rubbish at actually designing the UI of apps. We sort of try our best. But we've got a wonderful set of designers who work with us to help us on this. So we'll give you a very quick tour of the app just so you know what we're talking about. This is what we call the signposting page. It links to all the different parts of the app. shows you what you can do, gives you this idea of here's what you've just downloaded. And there's a bit we'll show you about how we've approached routing, which is to do with this. We found routing one of the most challenging parts of working with Flutter. Also one of the most challenging parts of working with React Native, which is what we used before. But we'd like to show you how we've approached that here.
It's a lot better with Flutter.
It's a lot better.
Still difficult, but a lot better.
Maybe we can have a look at the agenda. Or do you want to look at sponsors and speakers?
Sponsors and speakers, a place to start.
Great. So there are sponsors of the event and speakers. Now, one of the things I'll point out is the people who run the event are providing us with data to fill this. And they haven't provided us with all the data yet. They know we're releasing at the end of the week, but they haven't provided us with all the data yet. So some of this looks a bit sparse. When this has got more data in, there's a lot more kind of words there telling you about things.
We've only just persuaded them that Google Sheets is not a database, so we're at that sort of level. But we're getting there. We're getting there.
So you can type in, you can search for speakers. We use RX Dart for this with a little bit of debouncing with code that we found on Stack Exchange, like where all the code is. And it's a fairly standard. You can imagine it's a fairly standard Flutter layout with a column and some stuff like that. If you can heart there's little hearts there. They're a bit grey. You can say, oh, I want to have one of these as my favourites. You can look at speakers. Yeah, this all sort of is very responsive and reactive. You can look at speakers here. There's something else I just point out. Could you go back to sponsors? So we did a few attempts at this kind of page. What it does is it shows you the different sponsor levels. You've got 5-star sponsors. And if you scroll up there, it's some code some wonderful person who puts code on GitHub wrote, which is what do you call it? A header sliver list or something like that. Thank you. Did you write it?
I wrote one.
Nice. All right. I don't know whether we're using yours or not, but
What are you looking for?
we're just demonstrating the sticky headers. Once somebody else had written the code for that, it was super easy to do.
Yeah.
Although it blows my mind how it actually works. The thing that we found overall is that doing layouts in Flutter, if you get the data model right, so it's easy to lay it out, it's easy. So we've got a data model behind this that is, I think it's one of these multi-lists. So in the Dart collections library, you've got this sort of multi-lists where you say, well, you've got 2-star sponsors and you have a list of things under there, but you sort of manage as one data structure rather than this horrible nested thing. Once we'd figured out the right data structure to use, you can lay it out very straightforwardly and your UI code's nice. So that's generally what we've been doing. And it's just that kind of insight helped a lot rather than have multiple layers of model view models and all that kind of thing. We've said, okay, what we want to do is we want to have scope models. Scope models give you data in the format that's useful. We'll present that data using the Flutter layout things. That's just generally speaking what we found works for us. Let's have another look briefly at the rest of the app. Can we look at the agenda next?
By all means.
So the agenda is kind of, so it's on multiple days. You've got, again, it's a sticky header kind of thing. You can favorite things. You can go into them. Oh, and it doesn't lay out properly. Right, ignore that bit. You've got the little thing there. Right, well, it's not laying out. Right, so you got that. The cool thing is that when you're there at the event, it can be a hassle. Like when you go to the agenda, where do you want it to go? And the answer is you want it to go to what the time is now. And for those of you who followed Flutter issues or you've tried to build this kind of thing, there's been this long ongoing discussion in one of the issues, right? One long ongoing discussion saying, hey, how do you jump to a particular index within a list? Like when you've got one of these sliver lists or that kind of thing, how do you, when you got a custom scroll view essentially, how do you jump to this? And if you want to jump to a specific pixel location, that's easy. You just do it, or you animate to it, or you jump to it, it goes there. It's wonderful. But if you want to go to a particular item in that, it's all complicated. So various people have made various novel and wonderful solutions to that, like having 2 scroll containers that sort of magically work with each other to kind of pretend that works, or various other very complex solutions. We didn't do that. What we've done instead is we've got a fixed size or several fixed sizes for all the things on there and a bit of code that figures out how long it ought to be and then jumps you there. And we found once we'd figured that out and we'd agreed with our designers, you know what, this is always going to be the same height. And they said, oh, that's actually quite good because it looks weird to people if it's not the same height in this particular design. So they were happy with that. Once we'd done that and we'd agreed that, it was easy to get this kind of smooth interaction. And this was one of the things that converted our kind of business stakeholders to seeing that Flutter was a good thing, even though we're putting all this effort into rebuilding our app in Flutter. Because the React Native version of that was just really, I'm not going to talk a lot about React Native not being very good, because it is actually very good. We had a very good experience with it.
Yeah.
But this was so hard to do in React Native in a way that just instantly got you to where you wanted to go and worked. Maybe we were doing it wrong, I don't know.
We were doing it in quite a similar way, but it proved just tougher for some strange reason. It was a very, very strange thing. But it definitely was a far easier thing to get to with this. Anyway, there you go.
I'm going to speculate it's because of the handoff between native and sort of JavaScript and native, and the asynchronicity of rendering the native components meant that it was very difficult to jump to a place knowing that it had already been kind of rendered, and you'd get all these crashes, and the app would actually crash, and it would be awful. I'm sure we could do better if we went back to React Native with that insight. But having everything in Flutter down to the sort of skier rendering on there, like you don't have this sort of handoff to a different system, and it seems to make things more straightforward.
By the way, we don't work for Google. This isn't a sales pitch.
So there's the agenda. That's pretty much all we've got to say about the agenda.
Okay. Network or?
Yeah, go for it.
Network. Cool.
So network, it loads from the internet, loads from our back end, from an API, the people you ought to be interested in. You can search for them. There's this meet and greet section. We've integrated with a service provider called Sendbird. They do sort of chat capabilities. We ended up kind of writing our own version of their SDK because they don't do a Flutter SDK yet. And that's been kind of fun to do. The Flutter asynchronous stuff has been really good with that for us. There's a lot of asynchronicity in using WebSockets, and that just seemed to be quite easy for us to do.
Should point out the recommendations we're integrating with a third-party company whose server has been a little problematic today, and I'm wondering if that's what's causing this.
The last night nerves.
Yeah,
okay.
Possibly. But anyway.
All right, and let's have a look at My 2020. It's like once you've favorited lots of things, or you've agreed meetings with people, or there's certain other things you can do, it tells you your own personalized agenda. So that's basically what the app does. Yeah. If you pop into settings, one of the things we found kind of interesting to do in an events app was how do we test it? And obviously we write integration tests and things is what we're going to do. But until then, how do we test it? How do we give people the experience of a day at the event when they're sitting in the office a couple of months before the event? So we invented a thing called time travel, where it says our time machine, and you can click on day 2, and it changes all the times so that now your experience of using the app is as if you're in day 2 of the event. So if you hit the agenda now, you'll see that we're on day 2, and it's 5 p.m. because that's the last set of events there. So it sort of put you to the end of the agenda on day 2. So it makes it really nice to do that.
It was really useful for UAT that we could give this to the business and say to them, use this time machine aspect. And you can now get a feel for what the app is going to be like before the event, during the event, and after the event. And that gave them a huge amount of confidence in what we were producing and the user experience we were going to give their customers. So that was quite a nice piece of collateral for us to be able to give to them.
Cool. So that's our kind of tour of what we're doing. There's some more things we're doing to this, and some bits we haven't shown you that are more boring. Any questions about that? First of all, just what it is. Cool, right. So let's look at how we actually put it together. And the piece I want to start off in is where we start the app. We've defined, start app is actually called by, you can see up here, these different start scripts. So if you look at one of these start scripts, a start script is something we've hooked it into the, I don't know what they're called. The things in Visual Studio Code, you say here are the things you can use to start things from pressing the nice button at the top.
Targets for the run targets.
And all it does is it imports start app. It imports this thing called festival, which the festivals have a bit of a different theme, different colors, different graphics and stuff. So it's a bit like themes in Flutter, but we didn't find themes did what we wanted them to do because they're very material design-ish.
Just a little, so a small amount of background there. While we're not suggesting we're going to produce a single app that fits every festival going forward, because it absolutely won't. Every festival is going to have its own nuance and its own its own way it wants to present itself to its customers. What we do have is a fundamental engine on which we can vary, and so by having a lot of that variance instantiated in an object, a festival object, it just gives us the opportunity to effectively it's configuration. It's a little bit more than configuration, but effectively it's just the different configurations that allow us to take the different festival out to the app. And part of the thing that each festival needs to know is basically where its server lies. So
this is a JSON file. We stick it on CloudFront, and it's a JSON file telling it where the different API endpoints are. So it's a way for us. One of the things we wanted to do is to not have to run a backend for the app at the times when people aren't really using it very much, because it's between times on the festivals. And so the idea is that there's this JSON endpoint that tells you where the important endpoints are and how often we're supposed to poll them. And we can change we can either turn them off or change them into static files so that we have a worry-free way of kind of putting the app into a doesn't do very much but still works okay mode.
Don't have to keep paying Google for the server, basically.
Yeah.
Which is nice.
Don't have to keep paying you for the server. You can go and do something else with your time.
Absolutely.
So so there's that. Could you look in Start App then? Let's see how we start the app. Because this is one of the funny things. All the examples of Flutter apps I've seen, they have this, everyone's based it on the example app you get when you create a file. So you get this sort of app, and it's got a counter button on it, and you have Start App and whatever. There are a couple of things that just it took us a while to figure out. One of them was that we wanted to do a bunch of initialization and then do Start App, Run App. Because there's this thing where it keeps the operating system splash screen on the screen until you render the first frame of Flutter. So we've got a bunch of async kind of stuff that happens, and we time it. We've got a startup stopwatch there, and we say, well, we want the splash screen to show for a certain amount of time, because otherwise it looks weird. It's like, so we want it to show for a certain amount of time, and we're going to do a bunch of work. How long that work takes to do will depend on how good your phone is and how much data we've got and that kind of thing. So we time it, and we add the time later on. And then we set various things up. Some of this isn't all that interesting. There's a bug right now where you can't do full screen apps in Android in certain ways. So we found a workaround for that, which is here, and you can go look at that issue if you're working on Android and suffering from that. I hope it gets fixed soon. But otherwise, we get into the interesting stuff. We've designed the architecture of this around scoped model. We tried a block kind of way of doing things, found that confusing for teaching to new people, so we decided not to do that. We might reverse that decision later on, but that was the main impediment. It was just so much for people to learn as well as learning Flutter. We're like, yeah, you know what, let's not do that. We found scope model to be quite nice, provided we helped people to understand it. Nick, could you show us the app identifier block, or the app identifier model, sorry. If you look at model, and then, so we've got a directory. We've got a directory structure where everything's called model.
It's not at all confusing. Sorry, what's it under? It's under content.
No, it's under app identifier.
Then why am I not finding it? Oh, there it is.
There we go.
Gotcha.
This is the simplest model we've got. What it does is when you start the app up for the first time, it writes a UUID4 into shared preferences, and that allows us to uniquely identify that install of the app, which is kind of useful for certain things. We don't do advertising, so we don't use it for advertising stuff. But it gives us this ability to have this kind of consistency of interaction for certain algorithms. This is one of the simplest things. And if you look down here at the bottom, we got this app install identify model, extends model, and model is scope model. And you look down the bottom, we've got these kind of almost meta-programming sort of helpers. And so we have these kind of boilerplated into all our models. And what it means is that when you're doing UI code in Flutter, we can use of rather than have to do angle brackets, scope model stuff. It kind of gets very long and complicated to look at. You can just say app install identify model dot of context, and then you got it. Or you can say app install identifier with model, and that's a builder which you just have a builder with a single argument, which is the model. So it gives you this ability to have this updating model. The standard scope model has a builder which has a child and the context and stuff, which you don't use most of the time. But you got the standard builder there, which is the descendant builder. If anyone's who's familiar with scope model, just make sure I'm not talking. All right, scope model is this thing from Google, which has been ported over by Brian Egan and some other people for use in Flutter. So it's used in Fuchsia, which is the desktop version of Flutter. What it does, it's a combination of inherited widget and change notifier, basically, with some nice way of gluing it together that makes a very nice way to build fairly simple Flutter apps. And we've built a non-simple Flutter app with it. That's the basic sort of point of this talk, I guess.
And the point of this boilerplate is really, it doesn't do anything, as you can see, other than just hide the fact that you're using scope model with something that is easier on the eye when you read it. And that's a lot of our impetus in the way we've put this together, which may or may not come out, but has been to make this easy for other developers and other teams to pick up and run with as we move on to other things. So a lot of it is about wanting to communicate the ideas to other of our development teams as much as it is to get a working app out. So this just makes it pretty.
Could you pop into with model? If you just go into that. In fact, model only builder is where you want to go. Sorry.
Okay, thank you.
This is the code that makes that, so it's a bit meta-y. So I'm not expecting anyone to actually read that, but just to give an idea of, we sort of figured out how to make that do what we wanted, and then it becomes this 3-line boilerplate in our models that allows it to work in a consistent way without obscene amounts of typing when you actually want to use it.
Okay.
Yeah. So let's go back into startup. So we've got all these models. We start off by initializing these models. There's this general pattern where we say, set up a content model. The content model depends on the root config model and the signed in model, and we need to initialize it. Oh, let's go on to the next one, and so on and so on. And so we end up with this kind of web of dependencies. And this web of dependencies is the place we start when we look to understand what are we actually doing, how does it actually work. When you use scoped model, you can define some UI that uses scope model, and when you change the model, it notifies listeners, and that UI rebuilds itself. So it's a very straightforward way to get reactive Flutter apps. We want to do the same thing with our models, that when one model when one model updates, there's maybe another model we want to update in response to that, and so that's why we have the dependencies. And so this is the sort of map of our dependencies. Started off drawing it like this, then it got very, very complicated, so sort of just listed them down there. But this is the structure of our app, and that's what gets set up in startup.
Okay.
And so if you scroll down a little bit more, Nick,
Sure.
on there,
Where do you want to go to?
a bit further. After defining all of these models and hooking them up with their dependencies, we have this, which is in run apps. This is our run app. Say run app, here's a bunch of scope models, and we hook them up. And the reason we did this is, again, it's a sort of aesthetic thing. This is exactly the same as a massively nested set of children where each model has a child and it kind of gets nested way off the side of the screen. And you can kind of break that up in various ways, but it's still kind of ugly. So we have this thing called hookup model. If you could show hookup model for us, Nick. It's, again, a bit of dodgy metaprogramming stuff that just kind of, it inverts the nesting so that you can kind of have them in a row. That's kind of what it does. I'm sure there's a name for this. Those of you who like functional programming, there's probably a name for this. It's some sort of inverse currying or something. I don't know. But that's kind of where it is.
Cormering.
Cormering, thank you, Nick.
Inverse curry.
That's what we're calling it now. So that's basically what the app does. There's one more part to show just in terms of the structure of the app, which if you scroll down a bit further, we've invented a thing called a periodic updater. And what this does is there's sort of a protocol with each of our models where the model can define update. And update does some stuff. Update does some stuff, and when it's finished, it calls, it sort of does a callback of some sort to say either I've done it, I've done the update, and it was cool. So you can update again in some large amount of time. Or it says I tried to do an update, and it wasn't that cool, because of internet problems or network connection problems or something. So please try again quite quickly. And what we're trying to do here is give people a good experience at this event, where there's always dodgy Wi-Fi at these events. The Wi-Fi here is great, but in the events, when there's loads of people together, it just always gets dodgy. And so we want people to have a good experience. So there's this periodic updater. It's hooked into the app lifecycle event so that it only runs when your app's actually alive, and it runs pretty quickly when you bring it back from sleep. Does that kind of make sense? Yeah, that makes sense. And then it tries to have these two intervals of between querying to decide have you tried to get something from the internet and it's really not worked very well, in which case let's try again quite soon? Or have we tried and we got what we needed? Okay, that's fine. It's probably not going to update for a while. So it's this kind of optimizing the experience thing. There's one more cool piece of Flutter that I want to show before we kind of do a Q&A, I guess, or talk about anything else, which is this. You can't actually see it at the moment because the time is not right and the agenda is not right. But there's a red dot with the word now that would appear here on the agenda if that session is right now in process. And there's kind of an algorithm for deciding that. So we wanted that to kind of, we didn't want to just write some sort of layout thing that said, well, if that session's now, then show now, and then that's the end of it. We wanted to use this dynamic updating reactive kind of way of doing things. So what we've ended up with is some builders that work based on time. So could you find one of those builders for us, Nick?
Do you know which? Do you want to give me a name?
Yeah, if you look in the agenda card, there's no
session
agenda
card?
Session card. Thank you.
Okay.
No, it's not in the session card. My mistake. Sorry.
Is it near the session card?
It is. It's in the agenda time header.
Aha.
There you go.
Cool.
And in the agenda time header, you have here an interval builder. Interval builder. So the interval builder is, we say what intervals from Time Machine. A Time Machine, anyone know Time Machine?
Time Machine's very good. This is not the same Time Machine as we did earlier. That's a different Time Machine.
Time Machine changed our lives.
Yeah.
It's a port of Nodatime, which is a C# library, which has been incredibly well thought out about time, about how time functions. Because time's a complicated thing, and when we're talking about international audience, doing things at a particular time, but arranging things in their home time zone and then going to, it blew our minds. It was just horrible to try and get the edge cases and just figure it all out. Using Time Machine, it took us a while to get our heads around it, but once we did, it was wonderful. In fact, could you just bring up the web page for Time Machine? It's a bit confusing because there's all these distinctions between a local date time and an offset date time, and there's a zoned date time, and an instant and an interval, and all these are different aspects of time. An instant is a point in time, essentially the number of nanoseconds since the epoch, and that's put into an object called an instant. And an interval is some, two specific instances in that period of time between those two instances. And it turns out when you want to display an is it on now kind of red dot, well, the correct data structure for that could be an interval of time, which is the interval of time that thing's on for. So anyway, this is Time Machine. I recommend it if you're doing anything with time. Could you go back to the code for us, Nick?
Of course.
So here we've got our interval builder just here, and we give it an interval, which is the interval of time that should be shown for. And we have a fallback, which is here's what to do if you're not inside this interval, and here's what to do during the interval. And there's a few other things you can say, do something before the interval or after the interval. If you go look into Interval Builder, would you mind doing that for us, Nick?
Of course. I quite like this glamorous assistant role. It's quite good.
So there we go. It's a stateful widget. And you can imagine how you might build one of these. To start with, we built quite a naive one of these. It used future delays, and it kind of said, hey, based on when we're building, build a future delay until the next point in time that we care about, which is usually the start of the interval, or if we're in the interval, it's the end of the interval, so we can turn the thing on or off. And, rendering it here. So we're kind of rendering, well, 4 of them at once, but scrolling it, you're rendering a huge number of these. If you use a lot of future delays on iOS, on the simulator, you notice that your computer starts making whirring noises. And the reason it starts making whirring noises, if you look in your activity monitor, oh shit, thank you. Oops. You can edit that bit out. The reason it does that in your activity monitor is there's this service called Backboard D, which is part of iOS. And Backboard D is rushing around starting and stopping timers. Now, I thought future delays were free, essentially. They're not. They're actually really, really expensive. And you don't notice because you're only generally setting up like 5 or 6 of them and then leaving them. Once you're doing several tens of them or hundreds of them, you're just killing your phone's battery, or you're killing your laptop's battery as a proxy for your phone's battery. So instead of that, we built a different thing. Could you go up and find the all timer?
Well, any idea where?
Yeah, go to rebuild trigger.
Rebuild trigger.
And then in there, you will find a global timer. Sorry. Show global timer on line 7.
Show global timer, right.
So this is the ability to handle like hundreds of timers, essentially, but with one operating system timer, with a bit of kind of, maths or something like that to do that. So here you kind of got a tree set. The tree set's something from, is it from Quiver? Maybe it's from Quiver. It's from one of these collections kind of things. And the idea here is that you're saying, hey, I'd like a timer at this time, and then some other code can say, I'd like a timer at this other time. Oh, thanks so much, Simon. Appreciate that. I like a timer at this time, I'd like a timer at some other time, and that kind of thing. And rather than set up an operating system level timer for each one, it sets one timer for the next one. And whenever you change this, it goes and says, hey, what's the next one now? So you can see here, set trigger, saying like, well, in fact, could you look at refs by instant? That's probably the cool bit of code that figures it out.
Multi-map.
Yeah, can you see where we're adding it? No, maybe not.
Is this helping?
I'm not sure.
I get a lot of that.
Anyway, can you go down to reset timer? That's probably the key bit. So what we're saying here is that we find the next timer that's greater than the current time, and that's going to be the next timer. So even if we're dealing with 100 or 1,000 different time events that we want to have a timer to, it's like we just want to go to the next one. And that changed the performance of this from being like essentially making my computer take off due to hovercraft style levitation from the fans running to not being a problem at all. And I kind of think they should put this into Flutter, because otherwise you get caught out when you use lots of future delays.
Just to know, if anyone doesn't know, you can't cancel a future.
Oh, could you look up cancelable? No, we developed our own one because cancelable operation didn't do what we want. So this is cancelable delay. It's simpler than cancelable operation. So the deal, Simon was just saying, the deal with a future is if you do a future delayed, but then you cancel it before the delay, happens, that future is still going to run. It's just not going to tell you its result. And this is kind of rubbish for a lot of things. It's rubbish for a lot of things we're doing because we want to make sure that when the app goes to sleep, so when you kind of send it to the background, get a new app on the front of your phone, we don't want the app to try and do anything. Because if the app tries to do things more than 5 seconds, on iOS anyway, more than 5 seconds after you've put it to sleep, iOS will notice and go, this app's not being very good. And it'll kill your app, which means the next time someone starts your app, it'll take longer to start and you've got to reinitialize things and whatever, which is not very good user experience. So we wanted to try and minimize the amount of stuff we're accidentally running after the user puts the app into the background. So this helps us do that. So this is where we're managing a timer and a completer ourselves, and we cancel it before the future is. We have the operation that we want to do, and if we cancel it before the operation starts, well, we haven't actually started it, so we kind of get rid of it. Cancelable operation does something similar, but it's more complex because it tries to do more. So that's basically the tour we wanted to give, as well as potentially talk through some of the architecture diagram. How long do we have left, George?
How long do you have left as long as you need?
Oh, cool. Well, then I kind of want to do a bit of a Q&A because there's lots of different stuff here that people might be interested in, and we want to be as transparent as possible, right? When we get time, we'd like to open source bits of code that don't seem to be covered by maybe once we've written some tests as well, which don't seem to be covered by stuff that's out there in open source. We've sort of done a few things. One of the wonderful things about Flutter is we go and work on this for a couple of weeks. We look back and people have just written loads of really good stuff that we wanted to write.
Quite a lot by Simon.
Which is good. But yeah, I mean, I just want to open this up to questions. Like we'll show you any code you want to see. We'll talk to you about our experience as much as you like. Hey.
Hey there. I'd love to see how you did the time machine, your time machine, like 3 days ago, 1 day ago, and whether you've done anything clever as far as Flutter.
It's brilliantly clever because I wrote it. Well, I can show you, but it's in Elixir, not Flutter. So what it is basically it's a wrapper around our content. Our content is stored as a huge block of static data through CloudFront because we don't need to generate it dynamically. But what we do for the time machine is basically change the URL of the data to be an API endpoint, which takes a date and pulls the content JSON through, changes all the dates that are relevant according to the delta of the time you're looking for, and passes it on. So effectively, it's just a wrapper around the existing content JSON, but with the dates munged.
The key insight for us was, from a user experience point of view, we want to make it a simple push button. And the simple push button is, I want to experience, like if it's 6:30 now, or it's 7:30 now, I want to experience what it's like to be 7:30 at the event. The event's in a different time zone, it's on a different day, so we've got to take into account the time zone offset, we've got to take into account the day shift, and Nick's code does all that. And as far as the app goes, it just has to reactively reload all the data, and then the new data happens to be for an event that's happening in London today.
There's a little bit of sophistication in the front end. It needs to go from a static endpoint to a parameterized endpoint, but it's really, it needs to understand the parameter. But apart from that, it's really nothing very complicated. Apart from the back end, which is brilliant.
Anybody else? Zeno, you wanted to ask about open source?
It's not there yet, but will be. Yeah.
Hi. Have you had any problem with list views that has image inside it?
With what? Say again, with what?
Have you had any performance problems with list views that have images inside it?
Not noticeably, I would say.
So I have a simple list view that whenever I put a fairly amount of, maybe a small image in it, it keeps stuttering for some reason. When you do it, when you scroll like flick it or move it a little bit.
That sounds to me, and there will be people here who understand this sort of thing far better than I do, but that sounds to me like it's constantly rebuilding and redrawing the image.
I checked that. It's not that thing. So basically, every time that a new item wants to be created, it makes a big spike on the UI thread for some reason.
Is this a list view or a list view builder?
List view builder.
Oh, okay. I mean, I'd probably want to look at the code and have a play with it, but we haven't experienced that explicitly ourselves.
We got the one weird thing we got with list views, which the experienced people of you will go on, is where there were flashes of other images appearing, and then it would kind of rebuild itself, and that's because we had identical stateless widgets, but we weren't using keys.
Yeah.
So using keys was and figuring that out was actually not straightforward, partly because it wasn't straightforward.
Even though it's documented everywhere.
The hard thing is figuring out where to put the key, and which of your objects in the tree is the right one to put the key in, and how do you define the uniqueness of that key? Those two things were a bit subtle, and I'm not even sure I could describe the rules for this now, but I think someone's done an awesome video on how to understand the rules.
There's an interesting rule. If you have any widgets of the same type, same class, that are adjacent in the hierarchy, they should have keys.
Yeah.
Yeah, very interesting. A couple of questions. One is you mentioned you put UID into shared preferences to do something later with it. What was it that you were planning on doing with that? Is it for push notifications or something like that, right?
No, this is not. We recently integrated a thing called OneSignal for push notifications. Although those of you who saw the code, we actually commented No, the unique app ID is for this. We have we have some slightly complicated synchronization of bookmarks. So when you have saved favorites of different things, we call that bookmarks. And we want to support bookmarks synchronizing between different apps you've got, and also the website, and also certain other federating apps, certain other services. So it's a bit complicated to say how do you synchronize bookmarks, but how do we do that while keeping the code on the front end, on the app, as simple as we can. The observation we have there is that there is a linear sort of over time. There is a linear relationship between a single install of the app and the back end. So like if the app is installed on Nick's phone there and it talks to the back end now, it's not going to talk like twice at the same time to the back end because of the nature of one person using the app, but also the nature of Flutter being essentially single-threaded. So it means that we can say certain things about how to synchronize that data, which I won't go into because it's a bit kind of complicated, but you can say that. But in order to say that, we need to know that it is the same app talking to the back end over time. And so the easy way we do that is we identify that app. Some of the things we want to say apply even before you've logged in. So it's not about you as a user doing that, it's about this app having some sort of like identity over a period of time.
So it's an anonymous login from Firebase or something like that, right?
If you like, we're not using Firebase, but perhaps.
It's also about, it's not just about anonymous login, it's also in the instance where a single user, and we have this is quite a common use case at our festivals, a single user will have a tablet and multiple phones and will have the app installed on all of them and be logged in on all of them at the same time. And to keep bookmarks in sync across 3 different devices, you need to absolutely know that it might be the same user, but it's a different device that's currently looking to see what the state of the bookmarks is and currently updating the state of the bookmarks. Mm-hmm. So it's not enough just to know the user.
And the other question is, so you have some, JSON files that you are calling. Did I get it right that you call them every 60 minutes or something? And also, what happens when there is no internet connection? Is the app works, or what did you do for that?
Yeah, all right. So we check our JSON files every couple of minutes, so every 60, 120 seconds. When we do that, we add a fuzz factor to it. You don't want to have a thing where your app is trying to hit all the different services that happen to be in sync because it started up at the same time. So there's a fuzz factor of a couple of seconds when it tries to redo that. What was your other question?
Is it is there some mechanism for you to actually operate the app when there is no Wi-Fi?
Oh, sure. So there is a structure where there is a thing called a file downloader we wrote. And what it does is it tries to download, in the background, it tries to download a particular file from the internet onto the phone. It receives it into memory, then it tries to parse it. If it parsed it successfully, it saves it onto the hard disk of the phone in a particular location. And then it makes available the new data to the scope model and then updates all this and that kind of thing. The reason we do it in that order is because if you reload the app, the first thing it does on initializing is it reloads the stored data, and we want to only have good data that we've been able to parse to do that, and we parse it when we load it in, so there's a good chance that it'll still be parsable when we reload the app. So that allows the app to work offline. So it's this kind of pattern of having data that is held in the file system of the app, and then reloading that or initializing and saving that periodically when it's reloaded from the network. We've also, for many of the API calls, we check whether the domain is reachable before we make the call, making it more likely it'll be successful. But even then, it's going to be unsuccessful some of the time on a rubbish Wi-Fi network and various other things. So we just kind of were okay with that.
Fall back to the last successful data load we got. We also pay quite a bit of attention to the, as is pretty standard, we version the API. We also version the content schema because, as you can probably imagine, with complicated yeah, not too complicated, but relatively complicated data. Its schema will change over time. We will want the app to deal with that. And the app is therefore aware of the schema version it can cope with and won't touch any new data that is of a different schema version. It will stick with the old stuff it's got. For similar reasons, we have a forced upgrade. The upgrade model is a forced upgrade model, which basically overrides the UI of the app and says, hey, you've really got to upgrade now. We can't really service you as it stands. Go get a new version. So we proactively push our attendees to get the latest and greatest version of the app. And this is based on years of paranoia from working with, happened to be React Native, but could have been any app, where we got the bloody thing to the store and then realized there was something missing, which is usually a later feature request from the MD, so which is hard to...
Our audience for these events is typically, we did a similar app at Cannes Lions. Typically what we call creatives, the people who work in advertising, and sort of investors, business people, this kind of thing. Our research about how people use their phones is that many people anyway, don't seem to have automatic updates turned on. Many people don't update their operating system. Many people don't update their applications. And so that gives us a problem, because when we persuade someone to download the app that might be of help to them at this event, how do we get them to get an update to it? It can be very, very difficult if we don't have this sort of, some people might consider it an anti-feature that stops you using the app under certain circumstances until you've downloaded a new one. We've just found that that prompt is important to help people get the latest version of the app when there's something worth having there, that's worth having at the event with other people. So, does that sort of make sense?
Yeah, it does. So are you using some package for that?
We made it. So it was fairly straightforward to do in Flutter. We used the same infrastructure to download stuff. We download a JSON file that says, do we want to upgrade and what message to show? And then when you start the app, in our route navigator, the initial route is chosen to be, if you're signed in, then it shows you the main app. If you're not signed in, it shows you the sign-in page. But prior to that, if there's an upgrade to be done, then it shows you the upgrade page. So it's very easy to do once you've figured out how navigation works.
There you go, initial route. The upgrade model says an upgrade is needed. You go to the upgrade route. If we're signed in, go to the main route. Otherwise, onboarding. Dead simple. And again, because of this common architecture we're using throughout, it's just another scope model, which in this instance hits the upgrade backend API and helps make this decision on startup. The backend is a JSON API, yeah.
Hi. Sorry, one more question. If you had to estimate how much of time you spent in Dart and Flutter, and did you ever have to go off that into native code to kind of implement this app, or was it literally 90-95% in Flutter?
I think the first native code we've had to do is in the last couple of days. Is that fair to say?
Well, so I wrote a bit of native code. Wrote a strong word for this. I sort of copied it from other things and made it work. So when we first, we've got notifications in here. You can get notifications for the sessions you save and various other things. We wanted to do this thing where, rather than on iOS, rather than just give you this, do you want notifications kind of operating system dialogue with no prompting, no sort of explanation of why you should allow us to send you notifications. We wanted to do that. We wanted to have what we call a priming page or something, a primer, that says, hey, you should have notifications that will help you in this way, and we promise not to send you too many of them. The APIs we were using for notifications, the notifications package didn't allow us to do that. It was all or nothing, so we did that. Later we found that's available in OneSignal's API, so we're just going to get rid of our native code and just use that instead in the future. That was the first thing. Second thing I think was on the camera or the image picker.
Yeah.
Nick wrote a thing to allow you to have the front camera because we want people to take a photo of themselves to help with networking with people, but the image picker only has the big camera that points that way. Other than that, we haven't written any native code.
And how does that compare to when you were working with React Native, out of interest?
Huge amount, quite a lot of native code in React Native, I'm afraid. Yeah, I would say, I mean, I have very little experience of this, but just writing native code is easier in Flutter as well. The interface is, which I forget the name of. Thank you. Yeah, that's it. It's just far, far nicer way of dealing with that.
Cool.
Other
Thank you.
reactive systems are available.
Oh, Simon.
Just continued on the routing. When you do the loading of the app in the beginning, how do you switch between the load screen and the routing?
Oh, sure. So we got the splash screen. I mean, Nick, can you just kill the app and restart it? And I think you'll be able to reload it to show the splash screen. So do you mean like,
Come on.
so it's going to show this kind of power up the future of money thing?
Any day now.
So do you mean like transition between the splash screen and then the app? Is that what you're talking
Well, actually, between after the splash screen, if you want to have some kind of loader before you go into the routing.
about? Oh, we didn't want to do that. I mean, because
Sorry.
that's really slow.
I must have hit Command T at some point.
Anyway, that's the splash screen, and that's an operating system level splash screen. It's an asset in the iOS kind of thing on the simulator. And then it goes directly into the app, and in fact, it remembers the last place you're in the app. That's nice.
So you just delay until the
We
data is
delay
available,
on
and then
one
you.
app until we're happy that we've set everything
Oh,
up.
okay.
But we didn't want to have a Flutter rendered, what do you call it, splash screen. I guess didn't really have a need for it.
Okay, makes sense.
You did mention you've had a lot of fun with routing. I'm kind of curious, what were the problems you had and how did you overcome them?
Sure. So the Flutter way of doing routing is based around navigators and navigation and routes. Navigators, except for one bug that I'm very irritated by and I haven't figured out how to fix, to do with, I won't talk about that now. Anyway, navigators generally pretty cool. You can it manages a stack of things on the top and you choose which thing on the top you want to have and it sort of remembers where you are and you can push and pop them off. That's all great. There is this metaphor that we're not using, which is a sort of material Flutter kind of metaphor, which is, well, it's almost like a dialogue. It's saying, hey, I want to show you this route, and this is going to ask you some questions, and then we're going to pop that off and get the data back. So it's almost like a sort of asynchronous call. So that's this other aspect of navigation, and we're just not using that. So navigation for us is, what screen do you want to show? Remember what screen you showed, so we can go back there later. Push a temporary screen on top of that screen so that we can kind of animate that off later, and do so with the kind of transitions that our user experience people would like us to show. That's the limit of routing and navigation for us. The way we've done it is that we've got this this is something we've got this philosophy of make a big mess and repeat stuff as much as possible until we've understood what to do and then refactor it, rather than the other way around, because the other way around doesn't work so well. If you try and refactor before you've repeated yourself a lot, then it's kind of hard to know how to refactor well.
Dry. Do repeat yourself.
And this is not new stuff. There's a wonderful person of the Ruby community, Sandy Metz, who's done enormously good talks about this kind of strategy, except she writes tests as well. We don't. So, could you go to the routing model? Oh, you're there already?
Yeah, see?
Amazing.
See?
If you kind of scroll down a bit.
Where to?
We've got all these things saying go to now on agenda, and can you go down further?
Cute. Say when.
There are all these we're using global keys to identify where navigators are, which is the source of many bugs in Flutter. We're using global keys, so global key allows us to say, from like code that isn't really UI code, it says, I just want to grab the navigator that does this, right? So on the app, there's a navigator that sort of does this part of the app, there's another navigator that does this part, and inside each one of these, there's another navigator that sort of manages that. So we've got this kind of structure of navigators in the UI of the app, and we can grab them using these global keys, which you might have seen shoot by earlier on. And we sort of install them with these global keys so that we can grab them and do things with them, saying like, oh hey, you navigator, do this, and you navigator, do this.
They're somewhere.
There
yeah, right.
So you've got the app sections navigator is kind of the big top one there, and the homepage navigator, which is inside where the home is, and that kind of thing. And then if you scroll down for me, Nick, we've got all these methods which say go to particular places. So we've got one further down.
Go to profile.
Go
There you
to
go.
about me tags, go to profile. And the way it works is you sort of go to profile, asynchronous method, it logs the route we've gone to profile, it awaits go to my page. So what that means is if you're already on my page, that just returns. If you're not on my page, it navigates you to there. And the reason we wanted to do this is because in certain parts of the app, so we've got navigators for navigating in certain parts, and we've got tab views for navigating in others. And we want to have a cohesive view on this for navigation. We want to say, look, as a person, I want to hit this, and I want to be navigated to this view and this tab view.
For example, my profile.
So yes, that's sort of gone two navigations stacked one after the other. So it's kind of a different metaphor of navigation than Flutter has as its kind of happy default navigation. So I wish that tab views worked using navigators. I kind of think they should. If you're interested, I've got a pull request with Flutter, which I've been waiting like 3 months to get reviewed by something. If anyone from Google's here, I've been waiting 3 months to get reviewed. I'd really like to get reviewed. I've had loads of people, about 4 people, from the world who've encountered this problem, tried it out, found it to be useful. But it's a hassle to kind of keep your own version of Flutter. Anyway, there it is. It's a pull request. It's got my name on it. What it does, in the bowels of tab view, there is a horrible, horrible hack. So tab view manages children. Here, I'm trying to draw things. Right, here's tab view, okay? It's 3 tabs, X, Y, and Z, and it manages these 3 children. How does it do it? Well, under the hood, it's what's called a page view. I think I got this right. So essentially, if X is selected there, there's kind of 3 pages in a page view like this. Because they're slivers, it doesn't really bother rendering these, but they're there. If you use keep alive, it does bother rendering them, but they're there. And when I hit Y, it goes, oh, slide this over. It kind of slides over the page view, because it's kind of a scroll view here. And there's certain things this really screws up, by the way, the internal scroll views. Anyway, so it slides it over. So we're sliding over this way, and get rid of that. We now have, Y is selected, whatever's on there, Y. Does this kind of make sense so far? Yeah. Right, so start again. We've got X selected now, X, Y, Z. X is selected. I want to go to Z. There's this user interface effect called warping, where here's page Y, here's page X, here's page Y, here's page Z. But what we want to see is that page Y, page Z appears to be next page Y, and it kind of zooms in. Now, if I was building that, I'd want to use a navigator to do that and have a navigating transition. That's not the way it works in Flutter. If you look in the code tab view in Flutter, what it does instead is it says, okay, we're entering the warp. And it puts this kind of little flag to say, we're entering the warp. And what it does next is it switches around the children, because there's a whole structure of like children in the whole widget structure. So this tab view's got it's got a structure. Here's the tab view, and it's got children here. Like it's almost like it's a column or whatever. Think of it a bit like that. And it goes X, Y, Z. And this warp thing, what it does is it goes, oh, temporarily make a copy of Z there, so that when you shift the scroll view, it gives that effect. And then when you're done, switch it back. And this causes all sorts of problems. Some of the problems to do with keys and repeating widgets. If you're using global keys, it all just blows up because you end up with 2 global keys at the same time. All sorts of things wrong with it. It's kind of a horrible hack. Anyway, that's one of the problems with it. The other problem is it's not a navigator. And if you want to navigate, you kind of, it would be nice if there's a consistent API to say, go to this page by navigating to it, and go to this tab by navigating to it. So that's kind of why we did this. Sorry, a bit of a rant there. I'm just set my pull request. I'm sure the busy people will get around to it sometime. So that's kind of how we've done it. And so you end up with all these kind of stacked up saying, well, how do I get to profile settings? Well, make sure you're on the main app page, make sure you're in settings, make sure you're there, and the code just kind of does the minimum necessary to get you there.
Very interesting. Anybody else got some more interesting questions? Yes.
Hi, I have one simple question. So from the time that you got the idea of new application and you typed in Flutter create and the app name to this moment, how many time was gone and how many people were working on this project?
Yeah, really good question.
So, should we tell them? So we started preparing a demonstrator for Money 2020 Las Vegas, which was last October, and it was a month and a half, 2 months before that, month and a half.
So within 6 weeks of kind of coming to this, while doing other things.
Yeah, it wasn't full time.
Kind of skunkworks project.
Yeah.
We were kind of doing this in our spare time to start with, to kind of prove that Flutter was worth changing to. I mean, it's a hard sell, right?
Yeah.
If you've already got a React Native app that's sort of good enough, why would you change to something else? So we were trying to kind of demonstrate that rather than prove it by pointing at things people who said it's really good or saying, oh, well, look, the Hamilton app's really good. Rather than say, well, that kind of thing, we said, well, we've got to build it ourselves and show this. So we ended up building a demonstrator by that 6 weeks that had some of the key problems that we've shown could be better. So we showed that we could integrate with the native calendar because there was a very nice plugin to do that. We could do notifications. We had the agenda and then scrolling from the agenda working very well. The actual scrolling, as well as the jumping to now on the agenda, the scrolling was just smoother than what we had in the way we'd done it in React Native anyway. And certain other things. So we did that in about 6 weeks, and that was the end of October. Then, and that was pretty much, I would say, 70% me, 30% Nick, because Nick had more of a day job than me at that time. I
was doing the back end for the React Native app that was servicing, which is the predecessor to the one we have here, that was servicing Las Vegas, and I was basically sneakily talking to Steve and working out what the Flutter app needed, and then persuading the React Native guys that they needed to use the same API. It was quite fun.
And then after that, from the end of October or so, I mean, we have the show, and that's always a big deal when the show actually happens. We don't really get anything done then because we're supporting this going on. And so I think we probably had the month of December, except it's holidays and stuff.
Something happens in December.
And a bit of January. So there's probably 12 weeks, right, is fair.
Yeah.
Like if you said 12 weeks for 2 people sort of doing the back end and front end between them, that was sort of, I guess, something like that. That's very good.
One more?
That then leads to the question, so why did you opt for Flutter over React Native?
We didn't like the React Native developers, basically. We just wanted to piss them off. No, why? Because it's good, and our experience of React Native was not brilliant, which is arguably down to us rather than down to React Native. To be fair, it's a well-known system and it's out there, but we wanted something that made more sense, worked better. There's always that as well. Yeah. Well, absolutely. I mean, there was everything we read about Flutter made it look good. We tried it, and it turned out to be true.
I mean, my view is that I am okay with JavaScript as a language, but I find it irritating to do stuff in JavaScript because I feel that, well, in the realm of React Native, I always felt my learning curve was learning the idiosyncrasies, the knobs, how does it work for this component and this component and this component. And because they're all being developed sort of by different people, different styles and different approaches to reusability or consistency or just how we're thinking about them or openness to modification. It was just this very bumpy, flat, boring learning curve for me. And what I found with Flutter is that there was a higher level of basic engineering that was transparent to people just kind of dabbling in it. And I was sort of dabbling in it, and I found that as soon as I found a place which I didn't understand or that had some sort of a problem or whatever, I could inspect that, go into that, play about with it, and understand it more. And I had this way to go all the way down. I mean, we did something kind of cool with paragraphs. Could you go to the agenda? There was something I know the experience guy wanted us to do with paragraphs there.
Oh, sorry.
So you see this says, like, it's got these people, Freddie Kelly, Priya Sharma, Russell Kumar, +1. So we wanted to have all the speakers on one line. But sometimes there are too many speakers to have on one line. So we wanted to have this thing where you could have several speakers and then plus however many more there are fitting onto a line. I was like, how do I do that? Well, ended up, that's a layout builder doing that, but there's also some measurement of paragraphs and that kind of thing. And so in figuring out how to do that, I was reading the code to like text layout and steer and stuff like that to go figure out how to do these things. It's not very well documented, or at least the bits I was wanting to use weren't that well documented at the time. But just the code was clear. It was easy to see. It felt like a very doable thing. And I just didn't get that experience in JavaScript. So that was one of the reasons.
Well, the thing for me, having worked on the React Native apps previously for 6 months to a year or so, Steve said, hey, there's this really cool thing called Flutter. Do you want to have a play with it? Give it a go. And so I sat down and I sort of took a week working from home. Thank you. During which I basically just tried to do the stuff that had been difficult in React Native. So getting push notifications working for our chat system alongside our own push notification needs, which was very difficult in React Native. Again, probably because of the way we did it rather than anything else, but it proved difficult. And a number of other things. And it just sort of all fell together really easily with Flutter. And it was just a much more joyous experience. We don't work for Google. I should say that again. It's not a sales pitch. But it was just a good experience. And within a week, I'd done a demonstrator that looked horrible, but did most of the things that we'd found difficult. Yeah.
All right, one question from me. What kind of crash logging are you using? Crashlytics or anything like that?
So there's we can show you the code where it's hooked up, which is start at. Well, actually, probably falls into this thing called error reporting. So Sentry has, as an online service, it just looks nice and it works nice. We found it good. The way the less is errors when you've got loads of people using your app seemed to work quite well for us. We'd used Crashlytics previously, and that's kind of end of life now, so we should find something else. Or maybe it's changed into some Google thing. I don't know what the deal is there. There was some code in one of the example GitHub repositories along with Sentry that kind of gave me an introduction to how zones work. I hadn't looked at zones before. Anyone know what zones are? It's this kind of thing about Simon knows. It's this kind of thing where if you're running a bit of Dart, there's like, what is the context in which it's running? How does it know what printing means? How does it know what errors mean? Kind of thing. Probably a better way of putting it than that. But it's really important if you're doing error reporting. The zone allows you to catch errors that no one else has caught and do something with them without it, and it allows you to do so even in the presence of async code. So we got that. We initialized error reporting. A lot of this is copied up from something that we found showing you how to do this. Set up the Sentry client, stick stuff in it that's useful. And then if you look on the start app code, you'll see where it's got setting up zones. They run zone, future null, async, and that's where we do our whole start app kind of thing. And then at the end of that run zone, there is
Sorry.
that catches the errors. So if there's an error on startup, we show this broken app screen, which looks like a sad, smiley. We should show customers. See it in development. And otherwise, it reports this error, which sends it over whatever centralization or something. I don't know what it does about catching errors when you're offline. We get enough errors when we're not offline, but I haven't had to care about it yet. But that'd be an interesting thing. I thought we might combine with our analytics code. We've got an analytics code to store stuff on the hard disk in a quite efficient way and then sort of sends it off when it can. So we might end up using that for storing errors. Simon, you look like you know something.
I wrote it.
That's awesome.
At the moment, offline, it just falls on the floor and does nothing. Yeah, most of the Sentry clients do actually queue them up to be reset when it goes back online. Currently, the Flutter implementation does not.
Okay.
Currently, soon after this.
Maybe I'll show you what we did with our analytics code. It might be a good match, in which case we can just store it. If that's useful.
Cool.
Cool.
All right, I think that's enough questions for now. Maybe if the guys are around later on, we can ask them some more. Right, I suggest we have a 10-15 minute break while the next guys set up. Nevercode will be talking about their Code Magic tool.
Cool.
All right, thank you very much.
Thank you all.